Good day, grade 12 students. Your professor here. I've just received this packed question in my email from one of the students in grade 12, and I will imagine the student became a fish outside the water because of this question. However, this question is very popular and unpopular at the same time. Hence, I'm going to give a sustained argument, if not to apply both common sense and logic to this question. Let's check what we have here. Question 4. It's from Gauteng, June exam paper 2023. Let's check. They are saying determine the general solution of the following equation. I'm going to pen this equation down. That is to say 4.1, we have a cos of 54 degrees minus x, that is equals to sine of 2x. Now, guys, pay attention. You have got the cos of this angle, which is 54 degrees, take away x. And this side, you have a 2x. Now, these angles are different. By that, I mean, if you had a cos of y equaling to a sine of y, these angles are the same. Therefore, you could divide both sides by cos x, and you will have a tan of y equaling to 1. This is easy, and you guys know it, I know. But here, the angles are different. Therefore, assume that now I'm having the angle x. So this is angle y and this is angle x. So what I'm going to do now is to apply what we call co-functions identity, which states that the sine of x is the same as a cos of 90 degrees minus x. This whole situation here is the same as cos of 90 minus x. Therefore, I'm going to equate the angles and solve that algebraically. So I'm going to apply it in this question. Pay attention. I'm going to have cos of 54 degrees minus x is equals to. So the way I'm going to rewrite a sine of 2x, I'm going to apply what we call co-functions identity to say that this part here is the same as cos of 90 degrees minus 2x. It's the same thing. Think about it. This is 90 minus. That means we are in the first quadrant where everything is positive. That's why you have that sine of x there. So basically, this is the same as that sine of 2x in there. Why are we doing this? Is because we now have cos both sides of the equation. So I'm going to take what we call the reference angle. So I'm going to write the reference angle. So the reference angle, basically, normally, I actually advise my students to take the angle that is always on the right-hand side if the trig ratios are the same. In this case, we have cos and the cos. So I'm going to take the angle to be 90 degrees minus 2x. You could have taken this one, the answer would have been the same. But my advice is that you take the one on the right-hand side of the equation, okay? Please get that. So you have 90 degrees minus 2x. That is your reference angle. Now, you are going to check where is cos positive. So now, if I were you, I will draw this mini diagram here. Cos is positive here and here. Okay, and here is basically your reference angle. In the fourth quadrant, you have 360 degrees minus the reference angle. So that is going to give you your general solutions. Let's check. I'm gonna take this part here, which is my angle. When I have 54 degrees minus x is equals to the reference angle in the first quadrant, which is 90 minus 2x. When I have a 90 degrees minus 2x. Remember, this is general solution. You must add the period of the cosine, which in this case is 360 degrees, multiplied by the k, where k is the element of integers. Think about it. You want to solve for x. I'm going to transpose 2x this side. So as a result, I'm going to get minus x plus 2x. It's going to give me x is equals to 90 degrees, take away 54. That should possibly give me just 36 degrees in there, plus 360 degrees k, where k is an element of integers. Okay, so this is the first solution that you guys are going to have. You need to also write or the other one. So the other one is in the fourth quadrant. I'm gonna have 54 degrees minus x. So let's have that 54 degrees minus x, that is equals to 360 degrees minus the reference angle, which is possibly that stuff there of 90 degrees minus 2x. Don't forget to write your 360 degrees k, where k is an element of integers. I think from here it's you and the basic algebra. If you do it nicely, you'll have 54 degrees minus x is equals to 360 degrees minus 90 degrees plus 2x. Okay, so if you solve for x nicely here, you can really transpose everything there. That is going to be minus 3x. It's going to be minus 3x. 360 minus 90 is 270. And then you take away 54. So you have a negative 3x. You divide by negative 3. X is going to be equals to negative 72 degrees. Please, guys, use calculator if you're not sure. Minus 360 divided by 3. That is going to be 120 degrees times k, where k is an element of integers. Please, guys, don't divide this one by minus 3. You only divide the period and the prescribed angle of general solutions. Okay, now let's check the next question. I will use this one. However, there are two ways of doing it. Okay, let me show you the other way. Because this is a cosine, you could have said that you have 54 degrees. 54 degrees minus x is equals to plus or minus, because the general solution is the other way to say the plus or minus of what? Of the reference angle, which in this case will have been 90 degrees minus 2x. Okay, so if you solve for the first one, you'll get x is equals to 36 degrees, and then a plus 360 degrees. Basically, you're going to get the first solutions because it's the positive one, and then where k is an element of integers, or the negative one, it means it will be this one equivalent to the negative of that reference angle. And if you solve it nicely, you might get 144 degrees there minus 360 degrees k, where k is an element of integers. You could have solved it using this method. However, I advise my student to use this one because it's very popular to the grade 12 syllabus. Well, let me do 4.2 while I'm still having time here. That is 4.2. What are we given there? We are given that 13 sine of x plus 5 is equals to 0, where x is inclusive of 0 to 270 degrees. Okay, so I'm going to copy that, what we are given basically. So we are given 13 sine of x plus 5 is equals to 0, where the angle is inclusive of 0 to 270 degrees. Okay, so that is 270 degrees. I'm going to make the trig ratio the subject of the formula, which is going to be sine of x is equal to negative 5 over 13. We know these things very well. So what I'm going to do is I'm going to check in the quadrant where is sine negative. This negative tells you where is sine negative. Okay, so the way I'm going to do it, I'm going to be very organic now. Pay attention. I'm going to draw this whole thing here and try to analyze it. Okay, this is 0 degrees, this is 90 degrees, and then this is 180 degrees. Just right here in the third quadrant is basically 270 degrees. So they are saying this angle here, it's possibly from, it's a reflex angle. Okay, it's a reflex from 0 to 270. But hey, check in these three quadrants, where is sine and negative? Pay attention. Here, everything is positive. Here, it's only sine that is negative. And then here, that's where sine is negative. Therefore, I'm going to draw my diagram in there, in the third quadrant, where x is a reflex. Okay. So let me do that. Let's draw my right angle triangle. This line here is parallel to the y-axis. Okay. Well, This is the opposite. This is the hypotenuse. Okay, so you get 13 there. It's always positive, and then the negative 5 here. We can possibly use quadratic or working Pythagoras theorem here to say you get x squared plus y squared is equals to r squared. You're looking for the x. In this case, it's negative. It's negative in this region, so it's going to be plus or minus. Think about it. Okay, it's going to be plus or minus the square root of 144. It's 169 minus 25, so that is going to be plus or minus 12. Therefore, x is equals to negative 12. So in the diagram, I'm going to have a negative 12 there. Okay, so that is my diagram. Everything is put nicely. So that is the reflex angle. It's your theta. In this case, it's your x. So let's check what's the question. Find the value of sine 2x. So sine 2x is basically a content of grade 12. Okay, so sine 2x, it's a double angle identities, which is going to be 2 sine x multiplied by a cos of x. So everything is there in our diagram. 2 sine x. What is sine x in the diagram? It's basically what we had before. That's minus 5 over 13 multiplied by cos. What is cos? Cos is the adjacent, which is negative 12 over the hypotenuse, and that is 13. I advise that you guys use calculator. It's negative and negative. It's a positive number. So what is 2 times 5 is possibly 10 times 12 is 120. Okay, divided by 13 times 13, it's going to give you 169, and that ties down to the answer of this particular question. And thank you very much for watching. See you next time.